Algebra 1, Lesson 1, Part A is about adding and subtracting fractions. Okay, so we just have a review here. To add and subtract fractions that have the same denominators, we add or subtract the numerators as indicated. That would be the tops. And write the result over the same denominator. And then we have some sample problems. These already have the same denominator. So for the addition, we're going to add the numerators and write it over that same denominator. If you have 5/11ths of something and add 2 more 11ths of that thing, you have 7/11ths. And then when we're subtracting, again, they have the same denominator already. 5 minus 2, that's 3, and we keep it over 11. If the denominators are not the same, then we rewrite the fractions to make them have the same denominator. So that's what this middle part's going to be for here. Because in A and B, okay, the denominators are different. And so what we're going to do is look at what we have. We're going to find the LCM, the least common multiple, of these numbers, 3 and 5. That's 15. So we would have to add 5 to this one. Multiply it. And multiply this one by 3. And whenever you're doing this, whatever you multiply times the bottom, you have to also multiply times the top. That way, what we just multiplied by is the equivalent of 1, so we haven't changed its value. Okay, so we have 5 times 1 is 5 over 15, plus 2 times 3 is 6 over 15. And then we add, now that we have common denominators, we add the numerators. And there's the answer. On the next one, the denominators are 3 and 8. Okay, so the least common multiple of them would just be 24. We'll take 8 over 8 times this one, and 3 over 3 times the second one there. Multiply the numerators here. We have 16, and then the denominators over 24 minus 3 over 24, and then we subtract. Since we have the same denominator now, we just subtract the numerators, and it looks like we're getting 13 over 24. Okay, next, mixed numbers. A mixed number is the sum of a whole number and a fraction. So this notation, 13 and 3/5, does not mean we're multiplying 13 times 3/5. If that were the case, the 3/5 would be in parentheses. But instead, it means 13 plus 3/5. Okay. Now, when we add or subtract mixed numbers, we handle the fractions and the whole numbers separately. In some subtraction problems, you're going to have to borrow or regroup, whatever you like to call it. And we'll get to that, as it says in sample E down here. Okay, so for this one, we take a look at our denominators. They're not the same, so we're going to have to take care of that. We're going to be multiplying 8 over 8 times the first one, and 5 over 5 times the second one. So we're going to rewrite that problem with the common denominators. So we have 13 and 24 40ths plus 2 and 5 40ths. And then we can go right over here and write our answer. Like it said, we do them separately. So we have for the whole numbers here, we have 13 plus 2, 15. And for the fractions, 24 plus 5, 29 over 40. And then we should take a look and see if it reduces, or if the numerator is larger than the denominator, we'd have an improper fraction and have to simplify. But this doesn't have any of that, so we're done with that one. Okay, on the next one, it's the same mixed numbers, if you notice, so I'm not going to write my fractions there. I know this one's going to be 13 and 24 40ths, and then I'm subtracting from that 2 and 5 40ths. Same numbers, just now we're subtracting. Okay, and I do want to look here and see if I'm going to have to borrow. I know from what they told me above, I'm not doing that till E, but I'm just practicing checking that. So I check these fractions. I'm not going to have to borrow. So I can just go ahead and do 13 minus 2, that's 11, and then 24 minus 5 would be 19, and it's still over 40. So that's the answer to that one. Apparently on the next one, we're going to have to borrow. So same denominators still, 5 and 8. So I'm doing 8 over 8 times that one, and 5 over 5 times this one. 13 and 24 40ths, that one was actually the same as the other one, minus 2 and 35 40ths. Okay, so now we do have to borrow because 24 minus 35, we need the first one to be larger. So I'm going to go ahead and just rewrite it underneath here, I think. I don't have a lot of space over there. So we're going to take one from the whole number, add the equivalent of that to this fraction. So we're adding 40 40ths to this. That is 64 40ths. And by the way, you can set these up vertically. I should have shown one like that. But you remember these, I'm sure. Okay, so we have this minus that. Now we can just do 12 minus 2, 10, and 64 minus 35, 29. And that's still over 40. Okay. Now, example 1 looks like just more of some of the same of what we were doing, but these are similar to things you're going to see in your problem set. So it starts out with a nice review, like I said. We see things are supposed to be adding and subtracting all one problem. We also see they don't have the same denominators yet. So that's the first thing to do. And I'm going to go ahead and do what I did earlier and write beside these what I'm multiplying them by. And first I'm looking to see what it'll have to be. It looks like I need 6 over 6 times this one. We're going to be going for 66. So this one needs to be multiplied by 11 over 11. And this one will have to be 22 over 22. And again, you're just looking for the least common multiple of those denominators. Okay, so then we rewrite it with the common denominators. And that would be 60 over 66 minus 55 over 66 plus 22 over 66. And then we subtract, because order of operations, add and subtract left to right. 60 minus 55 is 5. So we have 5 over 66 plus 22 over 66. And then the only thing left to do is add. So we'll go ahead and add them. That's 27 over 66. And then we need to see if it simplifies. It does. I know both of those at least are divisible by 3, so I can go ahead and do that, and then I can see if if it will reduce any further. So when I divide that by 3, I get 9, and when I divide that by 3, I get 22, and this is just 3 times 3. 3 doesn't go into 22. This won't reduce any further, and I know I'm done. Alright, let's take a look at the back. Part B, lines and segments. Okay, so mathematical line. What it is a straight line with no width and no ends. To show its location, we draw a pencil line and put arrowheads on the ends. And to name it, we name any 2 points on the line and put that line symbol over them. So here's a line, and we're going to write all the ways of naming this line. Okay, so to name it, we need to name any 2 points on the line. Okay, AX. And then we put the line symbol over top. So line AX. Or you could flip that around, and it could be line XA. Maybe we don't use X at all. AC. Or CA. Or maybe we don't use the A at all. XC or CX. And there's no other combination. It's those. Okay, all of those are good names for this line. Alright, line segment. What it is part of the line. It contains the endpoints and all the points in between. So here's a segment. To show its location, we draw a line with no arrowheads, and we often put dots on the end, but not always. To name it, you name its endpoints and put that over bar over them. So this one only has 2 names. We can call it MC, segment MC, or segment CM. And that is how you read it, segment MC. And then up here, up here, line AX. Okay. In fact, I think maybe I won't make you go back up and write, but we're going to write that here. Segment CM. Okay. And actually, sometimes when they start talking about a segment like that begins the sentence, they'll write it like this. You may see that sometimes. So 2 letters without the overbar is talking about the length of the segment. Okay, so when you see MC without the overbar, that's talking about the length. This is talking about the actual segment. Okay. Example 2 here. I went too far. There we go. Segment AC measures 10 1/4 units. Segment AB measures 4 3/7 units. Find BC. So find the length of segment BC. Alright, so we know AC is this whole thing. AB is this little piece. So if we were to take this piece away from the whole thing, that would give us BC. So that's what this equation is saying. And we're going to fill in the numbers. That's what substitute means. And then after that, it's going to be like the stuff from part A. So AC is 10 1/4 minus AB 4 3/7. They don't have common denominators, so we need to take care of that. And I should have left some space so it's easier to show what I'm multiplying by. And so here we have 10 7/28 minus 4 12/28. And yes, we're going to have to borrow. So rewriting this, 9, and then 28 28ths plus this is 35 28ths minus 4 and 12 28ths. Okay, so now we can actually subtract, and we have 9 minus 4 is 5, and then 35 minus 12 is 23 28 units. Okay, I wouldn't have to circle the equals, but I'm not going to change that. That's our answer. And that concludes your notes. Enjoy your problem set.